ready, Miss Clarendon?
Mm-hmm.
Alright, so thank you so much, kiddos, for coming so quietly and so quickly to the carpet. You guys did such a great job. Alright, so today we're going to learn a little bit about magnets. Alright, I want you guys to know the standard. We're doing S1P2, and that's basically we can communicate information about magnets. We're going to evaluate magnets, and we're going to explore what magnets can do. Because the whole purpose of this lesson is to be able to explain what magnetism is. So you guys are going to be able to teach others about magnetism. Before we begin with magnetism, who can tell me what a magnet does? Audrey, what does a magnet do?
Well, it's useful for many things like credit cards, computers, and anything that's like phone that has magnets inside. And it's also useful for toys.
Yes, ma'am. All right. So we have magnets. Magnets can
Repel.
So when I say attract, what does it mean, Jada?
To stick together.
To stick together. All right. So if Jada and me were a magnet, would we attract or would we repel?
Repel.
Why?
Because it's not opposite.
We're not opposite, but Zakeem here, stand on up. Zakeem is my opposite. He's a boy, I'm a girl, so what are we going to do? Attract. Thank you very much. Alright, so before we even begin, you guys have a short video to watch, and it's about magnetism. And we're going to learn more about what magnetism is, so watch quietly and get ready.
Magnets are magnificent objects that create an area of magnetic force around them, which is invisible to the human eye. This area is known as the magnetic field. If a magnetic object is inside that area, it gets attracted towards the magnet and moves towards it without any physical contact. Looks like magic, isn't it? Now, what's a magnetic object? Objects that get attracted to a magnet are called magnetic objects, and the objects that do not get attracted to a magnet are called non-magnetic objects. For example, a piece of wood or cloth won't even move if kept near a magnet. But objects that contain iron, nickel, and cobalt will definitely get attracted to the magnet. When you keep a magnet freely suspended in air, it would rest in the north-south direction. The end that points to the north is called the north pole of the magnet, and the end that points south is called the south pole of the magnet. Well, I have a fun experiment for you. Take these two magnets. The north and south pole should be marked on these magnets. Now, bring the like poles near and see what happens. There you go. These magnets repel each other. Now, bring the unlike poles near. See? The magnets attract each other. This proves that unlike poles attract each other and like poles repel each other. Hiya! Well, if you cut a magnet into two, it won't lose its magnetic field, but would give you two new magnets. Trivia time! Did you know that the Earth behaves like a magnet? That's because the Earth's core is believed to be a mix of iron and nickel, giving the Earth its own magnetic field. If a magnet has a strong magnetic field, it can pull objects even underwater. Tune in next time for more fun facts. This is me zooming out.
Alright. So magnetism is an invisible force, meaning we cannot see it. And it can basically push or pull. Right. Now, if I break a magnet in two, it is still a magnet. So it doesn't lose. But when we have two opposite poles, the opposite poles will repel. So if you notice here, I have already a north and a south pole. By the way, we know that the North Pole is located in what part of the world?
Canada.
Canada. And if the North Pole is located in Canada, where's the South Pole located in?
Ocean.
Is it Atlantic or the Pacific?
Pacific.
Pacific Ocean. What we're thinking of when we think of Atlantic is Lewis and Clark and how they traveled across the Atlantic
Ocean.
And now that brings us back to just integrating a little bit. Lewis and Clark and Sacagawea, what were some of the things that Lewis and Clark had to pack in their luggage or in their things to help people find direction? What was the one most important thing that they packed? What was it called? Lily? A compass. A compass is basically one of those objects that shows us direction. Now, if you look here, we have a magnet suspended from the ceiling. And what we learned about magnets when they are suspended from a string is that the North Pole will always face north. So if this is the North Pole, then this direction here is the
South Pole.
Is the South Pole. All right. Now, when we think of iron, nickel,
And cobalt.
those are metals that attract to magnets. What are they again?
Iron, nickel, and cobalt.
Now I have on copper here.
Copper.
Is copper the same thing as iron, nickel, and cobalt?
No, it's metal.
It's a metal, but does it attract?
No, it's not the certain type of metal.
It's not a certain type of metal. It has to be.
Iron, nickel, and cobalt.
So this gold right here.
No.
No?
No.
None of this, huh?
It's a type of metal, but it won't attract.
What about copper? This is copper.
No.
What about the gray iron and the earrings?
No.
What about lodestone?
Lodestone would work because lodestone is made of
Iron, nickel, and cobalt.
And so you're remembering the social studies lesson that we talked about where we had the shepherd walking across the desert and he came across
Lodestone.
lodestone.
And then the lodestone picked off the nails on his
And the
shoes.
lodestone pulled all his nails out of his shoes.
Can we see?
So now I want to show you something. Say for instance we have two paper clips.
Paper clips.
And then in order for this experiment, we're going to explore a little bit about magnets. All right, so I have two paper clips here and I have one magnet. Remember, magnets can attract, come together, like this magnet, or we can flip them,
And
and then they will
one.
run or repel.
Hell.
All right, so they were repelling, now they're attracting. They're attracting all over the place, aren't they?
What is track?
Attracting
Together.
them together. So this will be a form of attraction. But not all magnets will attract like that because you have to have a north
In the South
and a
Pole.
south pole. Alright, so we're looking for a north pole here and a south pole. Let's see if we can get one. Can't get one that way, can we?
Oh, I didn't know that one was
Oh.
When I was in kindergarten.
Wait, what do you notice what's happening? What is this called?
It's repelling.
It's repelling. Why?
Because it's the same pole.
So it's the same pole. So it's not opposite. You're right. Okay, so watch me. This is an experiment. We're going to explore what would happen to a paper clip if I rubbed it against a magnet or strike it against a magnet about 50 times. So watch me. Or 20. I don't know if 20 would work, but we'll try it. All right, so this is about 50 times. I did mark the North Pole. All of your paper clips are marked. North and south. See that? All right. Now that's 50. I'm going to mark the next side. Still the North Pole. And notice that I'm keeping my magnet on the same
Direction.
The same direction. I'm not changing it around because we want to create magnetism. And magnetism is an invisible force. It can pull or attract objects. It might. Remember also the magnets are made of what?
Iron, nickel, and cobalt.
They attract to iron, nickel. They're made of lodestone, but they attract to what?
Iron, nickel, and cobalt.
Alright, so we've got our magnet. Let's see if this works.
Cobalt. Iron and nickel. Do they stick?
I don't know if it's sticking. Maybe I need to rub it some more. Now, can we rub the paper clips at the same time?
Yeah. No.
You probably can.
Because it'll mess up it.
Because it'll mess up the what?
Magnetism.
Magnetism. And my paper clips aren't attractive. But guess what we're going to do?
What? Do it again.
We're going to experiment to see what happens. When you rub paper clips against a magnet. Are you ready?
Yes.
Are you ready?
Yes.
Okay, so listen up. At your seats, you all have a magnet and you've got 2 paper clips. Find yourselves at your seat. In 5, 4, 3, 2, 1. Alright, so now look at your paper clips. One side is already previously painted for you. It's painted red. So, you're going to grab one paper clip and you want to grab your magnet only on one side and you want to strike it about 50 times. Alright, get ready. Start. Scratch, 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 scratch. Alright, so the world is made of a huge magnet because its core has iron and nickel in it. That is what causes the rotation to happen. Keep going.
You did it. It's actually a slapping.
Keep going. Keep scratching. Scratch, scratch, scratch.
I think you did more than 50 times. I did more than 60 times. Oh, she said 50.
Keep going. Scratch, scratch, scratch.
It looks like it's been more than 50 times.
All right, well, change it up. Let's go to the next one. Put that one down and scratch. Scratch, scratch, scratch. Keep going.
It worked.
Keep going. Scratch, scratch, scratch.
Behave like a magnet. Paperclip. Your magnetism went out. Yeah. Oh, you think so? Watch when it's happening. Watch when Christmas. Christmas can be it again. If you do that, put it on and then do this. Miss David,
Oh, she's got magnetism.
But I want to make my magnet super magnet.
All right, so we've got lots of magnetism. His is real strong. You need help, okay? All right, so you know what I noticed with mine? If yours isn't sticking, maybe you might have to go.
Miss Davis, mine is working.
She's got hers working.
Oh, it fell.
Sankeem's is working. Scratch, you gotta scratch. Scratch, scratch, scratch.
Whoa.
So if it's not working, chances are you did what?
The wrong pole. The same
The wrong what?
pole.
So that means you gotta keep your magnet positioned in one spot, and when you're scratching, you want to use the same pole that's painted. And that's what you're scratching. Now, if you're trying to pick up the opposite pole, will it attract or will it repel?
Repel.
If it's opposite, opposites attract. But if you try to pick up the same pole, what will it do? Repel, which means you won't be able to pick it up.
I fell.
Oh, we've got another magnetism going. Gotta keep scratching.
Oh, I got a trick.
Keep scratching. Scratch. Scratch, scratch, scratch. Lay it flat. So you want to just kind of wave it over. You don't have to necessarily touch it. You just want to wave it over.
Mine, guys.
See how the magnets start moving now? So you want to do the same with this one. And get the magnetism going. About 50 strokes. We lost our magnetism. It's almost there though. But you can't go with the same side. You've got to go with opposite sides. So keep striking. It's going to work. It's going to work. It's going to come off. It's just a light magnetism. And magnetism is what? Can you see it? It's called invisible. Yes. And you rub yours. You're almost not even touching the magnet. You're kind of like just rubbing it over. See, it's not really touching, you're just rubbing it over. But you gotta do it 50 times. Just rub it like this. You don't necessarily have to touch it. Just, yep, that's good, Jada. You're good. Keep going. Keep going. 50 times. Keep going, keep going. Then count. Keep going. There you go. Keep going. You got it.
Metal that can contract, right?
All right. So Aaron has a thought. I need you quiet and listen to what Aaron has to say. Aaron, you have the floor. Tell your classmates what you just told me.
So, you know how the magnets contract to the earth? So the earth connects to the moon so it can circle around the earth.
And why is it doing that? What does the Earth's core have in it that's causing that?
Iron and nickel.
Iron and nickel. And not what?
Cobalt.
Cobalt. All right, so class. I need you all to join me quietly. Leave your paper clips and your magnets at your desk. Join me quickly.
I did it.
I saw
Last time it didn't work.
I saw that. Alright, so we're moving. You should be down in 5, 4. Everybody should be here. 3, 2, 1. Alright, listen. All right, so magnetism is a force that is invisible. And when I say invisible, close your eyes. Can you see anything?
No.
So let's make it personal to you. Invisible means you cannot see. This force only pulls on some metals, such as iron. A magnet will not pull on copper or wood either. So we think here, let's make it personal. Magnets won't pull on books.
No, that's
Magnets won't pull on hair. Magnets won't pull on markers. And now, do I want to touch my smartboard with the magnet?
No!
Oh my goodness, well, somebody please
It
tell
will
me
mess
why.
everything up.
What? Why? So this is what we know.
And you put it by your credit card, it will mess up the code.
Okay. So you're saying if I use my magnet, that I could possibly tear my smartboard up? Because my smartboard has lots of what in it? And it might mess up the magnetism that helps objects inside the smartboard move?
Don't put
Oh, okay. Well, thank you for telling me that. Now, let me ask you a question. I didn't touch it. What about, would it be wise to keep my magnets near my computers?
No!
Oh, no. Why?
It'll mess up the computer. Because computers are made of magnets too.
All right, so let's finish this lesson out. I need you ready in 5, 4, 3, 2, 1. Cross your lap. So now, today we learned that magnets can attract or repel. Attract, come close, and repel, push away.
Push away.
All right. Magnets stick on certain objects. They don't stick on everything.
No,
They have to stick on
iron, nickel, and cobalt.
the Earth's core is a huge magnet, and that's what causes it to revolve around the Earth.
What?
The Earth's core is made of
Iron and
not cobalt. But now let's stop and think. When I say revolve, what am I doing here? Make it personal. So what does the Earth do?
Rotate.
It rotates. So if I'm rotating, the Earth is rotating, guess what happens? That huge magnet is part of the Earth's core, those hot molten metals, those metals are causing the Earth to act like a huge magnet and to rotate.
Can we watch them? And that's how the clouds.
Now, magnetism is an invisible force. It can push or repel. Remember, the whole purpose of your lesson today was I can explore and teach others about magnets. Now, how? How can you explore and teach others about magnets? What experiment did you guys just do? Jada?
We did, if you rub a paper clip onto your magnet 50 times,
It'll
it'll attract to the magnet.
it'll attract to the magnets. Also, we also learned that two
Magnets stick together,
but they have to have
the
opposite
poles.
poles. So two south poles, will they come together or will they push away?
Push away.
They will repel or push away. The North Pole is located in what part of the world?
The Pacific, Canada.
Canada. The South Pole is located where?
Pacific Ocean.
All right. So now that we know that, can you teach somebody about magnetism?
Yes.
Can you tell them that it's an invisible force that you cannot see, but it
Why?
pulls and attracts objects together?
YES.
Can you tell them that these particular objects that it pulls have to be made of
Iron, nickel, cobalt.
iron, nickel, and cobalt? Well, it seems like you guys have a lot that you learned today. So it seems like you were ready. You guys have done an amazing job. I want to thank you so much for such hard work. Find yourselves back at your seat. Thank you and bye. 4.